Who would have thought that the watchful eye of the James Webb Space Telescope could spell the end of the universe? Researchers recently published a paper proving that the universe may be finite after all. Has Webb done what scientists have been trying to prove for decades? If the universe is truly finite, this discovery would fundamentally change astronomy and our understanding of the universe. The question of whether the universe is infinite or finite seemed unanswerable until the James Webb Space Telescope unearthed new evidence. Even Einstein, the brilliant mind behind much of modern physics, had trouble with the concept of infinity. When asked, he wittily said, "Two things are infinite, the universe and human stupidity. And I don't know much about the universe." Throughout history, people have often had misconceptions about the universe. In ancient times, people thought the earth was flat and the sun revolved around us. Later, they believed that the Milky Way was the entire universe. Now, we are more open to the idea that the universe has limits. Researchers have left this question open without any definitive evidence in either direction. However, there are two main groups in the debate: those who believe in an infinite universe and those who think a finite universe is more plausible. Since the advent of the Big Bang Theory, many scientists have assumed that any object that has a beginning in time must also have a boundary or end in space. For nearly a century, the Big Bang has been considered a scientific fact supported by many observations. However, the James Webb Space Telescope has provided observations of hundreds of galaxies that appear to have existed earlier than expected, casting doubt on the Big Bang model. Scientists are beginning to realize that their long-held models may be flawed, and this change is not easy to accept. This new evidence makes the origin of the universe a matter of speculation again. So what led scientists to assume that the Webb telescope had found evidence of the finiteness of the universe? The cosmic horizon is the limit of our observable universe, about 46.55 billion light-years around us, making the visible universe about 93 billion light-years in diameter. But this cosmic horizon is not the end of the universe. It is simply the limit of our observational capabilities. Even if the Webb telescope finds a giant gap beyond this horizon, it doesn't prove that the universe has an edge or an end. It simply means that light from this distant region doesn't reach us. Previous observations have found large gaps in the visible universe, posing problems for cosmologists in our understanding of it. Einstein's equations don't account for such gaps, but they do exist. This discrepancy has led some scientists to theorize that the gaps aren't empty, but might contain undetectable matter. This view is consistent with the idea that while we haven't found any edge or limit to the observable universe, we've also found no compelling evidence for a spatial or temporal boundary within it. The expansion of the universe, observed by astronomers such as Edwin Hubble since the 1920s, suggests that the universe is growing. This expansion was widely accepted as the idea of the Big Bang. Scientists initially thought that this expansion suggested one of three possible scenarios: the Great Rip, in which everything is torn apart; the Big Freeze, in which the universe expands until it runs out of energy; or the Big Crunch, in which the universe collapses again. However, recent discoveries made by the James Webb Telescope have called these scenarios into question, suggesting that the universe may be expanding unevenly. The idea of a cyclic universe is gaining popularity, especially with the support of British physicist Sir Roger Penrose. In this theory, the universe could go through a series of cycles similar to the Big Bang of expansion, collapse, and rebirth into new events. Penrose's theory is based in part on the form of radiation that could come from black holes. This concept is consistent with the possibility of a universe that has stages but no final end. Could our universe exist in a larger multiverse? Growing evidence from physics and astronomy points to the idea that our universe could be one of many. If this is true, reaching the edge of our universe would not be the end, but rather the transition to another universe. It would be like crossing a border without saying a word. In fact, subtle discrepancies in measurements of the expansion of the universe could hint at such a boundary, which could suggest that another universe exists beyond ours. The strange ancient galaxies discovered by Webb could belong to parallel universes, lending weight to the multiverse theory. Just as boundaries can be defined by distinct changes in language, culture, or symbols, the boundaries of our universe could be marked by unexplained objects or cosmic phenomena. The James Webb Space Telescope is currently comparing data from the cosmic microwave background, CMB, to actual objects in the observable universe in search of additional evidence. While some cosmologists claim that the CMB already contains hints of the Big Bang, others believe it hints at a multiverse or an eternal universe. Advanced tools like the Project Flamingo simulations help scientists simulate the large-scale structure of the universe, potentially revealing signs of these multiverse boundaries or transitions. Ultimately, projects like the James Webb Space Telescope are giving us new insights into the nature of the universe. Whether it's part of a multiverse, a cyclical entity, or something we haven't figured out yet, these discoveries are pushing the boundaries of human knowledge and inviting us to explore questions we once thought unanswerable. The connection between black holes and their host galaxies is essential to understanding the formation and evolution of galaxies. Black holes act as the central engine that influences the growth and structure of galaxies over billions of years. By studying black holes, astronomers can learn about the processes that form galaxies and the large-scale structure of the universe. This complex relationship highlights the importance of black holes in cosmic evolution and the ongoing transformation of the universe. Black holes are fascinating and essential to galactic dynamics, but they can also be destructive. The immense gravity they exert can destabilize any celestial body that gets too close. Fortunately, current astronomical evidence suggests that Earth is in no immediate danger from a nearby black hole. However, the universe is full of surprises, and the study of black holes continues to open up new insights into how the universe works.